everyone, my name is Palki Jain, and if you haven't subscribed to our channel, then consider it right away. Now in this section 1.2 of the chapter Acid, Bases and Salts, we are going to study about properties of acid. So in the last section, we studied about what are acids, what are strong acids and weak acids, and what are bases and what are strong base and weak base. Now in this section, we are going to study about properties, and this is one of the most important topic of this chapter. So let's start with that. Okay, so the first property is acids are sour. So acids are sour in taste. Now the question arises, why acids are sour? So this is due to the presence of H plus ions. So how does it taste? It tastes sour, no? So it is because of the presence of citric acid in the lemon that it tastes sour. Now talking about apples, so they also taste a little bit sour. This is all because of malic acid present in those apples. Okay. Now this is curd. So we all know that in curd lactic acid is present, and that is why it tastes sour. Again, tomato, it also contains an acid which is oxalic acid. And a last example here is vinegar. So vinegar is what? Vinegar contains 5 to 8% of acetic acid, and it also tastes sour. So the first property is acids are sour in taste. Next is acid turns blue litmus paper to red. So what is litmus paper? So litmus papers enable us to tell whether the solution is an acid or a base. So this litmus paper comes into two colors. One is blue color and the other is red color. So if you can see here, we have a blue color litmus paper and we have a red color litmus paper. Okay, so we have a complete section on indicators in separate video. Right now just understand that we have a litmus solution. Okay, now if we dip the paper in the blue color litmus solution, then we will get the blue litmus paper. However, if we dip the litmus paper in the red color litmus solution, then we will get the red color litmus paper. Okay, so now suppose we have an acid solution here. So this is HCl solution in this beaker. Okay, and we had this blue color strip. Now when we have inserted this blue color strip inside this solution, then see here the color is changed to red. So acid turns the blue litmus paper to red. Now if I talk about the mnemonic to learn this, so acid is A, then B, then R. So acid turns blue litmus to red, ABR. So ABR can be a mnemonic device to remember this, because sometimes we get confused. So for acid, remember ABR. Now the third property is that acid conducts electricity. Okay, now the solution which conduct electricity are called electrolytes. Now there are two kinds of electrolyte, weak electrolyte and strong electrolyte. Okay, so in aqueous solution, acids ionizes in order to form H plus ion along with the formation of a negative ion. So due to the presence of these ions, the acid actually acts as electrolyte and thus conducts electricity. So if you see the figure here, you have a beaker in which you have an electrolyte. This electrolyte is dilute HCl solution. You had two nails which are connected to the negative and positive terminal of the battery. So once the electricity is passed to the solution, it will dissociate into H plus ion and Cl minus ion. So the H plus ion will move towards the negative terminal of the battery, which is this, and the Cl minus ion, being the negative charge, will move to the positive terminal of the battery. Okay, that's why we can say that acids conducts electricity. Now one thing more, that these H plus ions combines with a polar water molecule in order to form hydronium ion. So basically H plus ion is not a stable ion, and that is why it combines with the water in order to form the hydronium ion. Now let us see what will happen if we will have a strong acid as an electrolyte and a weak acid as an electrolyte. So here we have taken the HCl as a strong electrolyte. So we know that HCl is a strong acid, and that is why there will be lots of ions, and thus the electricity will be produced, and that too in a very high quantity, and that is why see this bulb, it is glowing so brightly. If I talk about the weak acid, which is carbonic acid, so it is also dissociated into its respective ion, which is hydrogen carbonate ion and H plus ion. Now, since it is a weak acid, therefore it will produce only a few amount of ions, and that is why the bulb which will glow here will not glow so brightly. Okay, so we can say that weak electrolyte is made up of weak acid, whereas the strong electrolyte is made up of strong acids. Now, with the same property which we have studied, we have a concept here. So the concept is not all compounds containing hydrogen will conduct electricity. For example, you have alcohol. So what is the formula of alcohol? It is C2H5OH. Basically, it is the formula for ethanol. Okay, and we have glucose, C6H12O6. So although they contain hydrogen, so we cannot say that they will conduct electricity because their hydrogen doesn't separate out into its respective ions. They do not dissociate into H plus ions, and that is why they do not conduct electricity. For an example, if you see this figure here, you have two beakers. Here you have dilute HCl, and here you have glucose solution. So once you put the switch on, this bulb will glow, which has the electrolyte as dilute HCl, whereas the other beaker which has the glucose solution as an electrolyte will not dissociate into its respective ions, and that is why there will be no movement of ions, and thus bulb will not glow. Okay, so this is one of the most important concept of this topic. Now the next concept is on dilution. So basically the acid which contains minimum possible amount of water is called concentrated acid. So if you increase the amount of water in this concentrated acid, then the concentration of the acid will decrease, and we will say that the acid is getting diluted. Okay, and this process is called dilution. Now this process is highly exothermic. It means large amount of heat is evolved once you mix water into the concentrated acid. So you have to be very cautious about it. Thus, we should slowly add concentrated acid to water. Okay, so what is the theory here? Like suppose in this beaker you have water. Okay, and you have to dilute certain acid. So what you are going to do is you will slowly add the concentrated acid in this beaker while you keep stirring it. Okay, so what happens is once a small amount of this concentrated acid is dropped inside this water easily absorbs the heat energy which is evolved, and thus the excessive burning can be avoided. Therefore, we always say that the word of caution is always add acid to water. Now, you cannot add water to concentrated acid. This is very dangerous because say suppose in this beaker you have the acid and you start adding water to it. Okay, so as soon as you add the water, large amount of heat will be evolved from this acid and it could cause excessive burning. So this is the word of caution. Do not add water to concentrated acid. It is always vice versa. You need to slowly add concentrated acid to the water and you have to keep stirring the solution. The next point is that acids have corrosive nature. It means on whatever it gets spilled, it actually eats it up. For example, the mineral acids can cause severe burn on the skin, and talking about cloth, if the acid is spilled on the cloth, then it can actually eat up that material and can cause hole inside it. Other metal structures and stonework can also be easily corroded by acids. That is why we never store acids in metal container, because it can easily corrode the metal containers. So all the acids are kept in glass or ceramics. because they are not attacked by acids. Now let us understand the concept here, which states that acid doesn't show acidic behavior in the absence of water. So what do we mean by that? Actually, we have already discussed that acids are the substances which on dissolving in water gives you H plus ions. Okay, now here is a small experiment which tells you whether H plus ions are important in order to show the acidic behavior of a substance or not. So here if you see, we have sodium chloride here and we are adding concentrated H2SO4. So when the sodium chloride reacts with H2SO4, a gas is released and that gas is HCl gas. Now if we bring the blue color litmus paper near to this gas which is actually coming out from here, then there will be no change in color. Although we know that HCl is a very strong acid, since this gas is not changing the color of this blue color litmus paper. Now what we have done is we inserted this blue color litmus paper into water, so that now we have moist litmus paper, and now when we bring this litmus paper near to the HCl gas, then we see that the color of litmus paper is changed from blue to red and it shows that it is an acid. So can you tell me why does it happen? So basically what happens is HCl, when it was gas, it did not dissociate into ions, whereas when this HCl gets in contact with moist litmus paper, so it breaks down into H plus ion and chloride ion. So because of the presence of H plus ion, we found that there is change in color. So we can say that the separation of H plus ions from HCl molecule cannot occur in the absence of water. Thus, HCl gas shows the acidic behavior only in the presence of water. The next concept here is distilled water doesn't conduct electricity, whereas rainwater does. Why? So let me tell you that distilled water does not contain any of the ionic compound. It does not contain any acids or base or any salt. Okay, whereas the rainwater, while falling on earth, comes in contact with oxygen present in the air and carbon dioxide present in the air and form different kinds of acids. For example, it forms carbonic acid, which is H2CO3. Now this H2CO3, which is carbonic acid, dissociates into H plus ion and CO3 minus 2 ion, and thus rainwater conducts electricity. Also, rainwater may also contain dissolved other gases like SO2, NO2, etc. present in the atmosphere, which can further help in the conduction of electricity. Now let us study the fifth property of acid. So it says that acid reacts with metals in order to form salt and hydrogen gas. So that is why it is written here, metal plus acid gives you salt and hydrogen gas. Now take an example. For example, I am taking zinc as metal and I am making it react with H2SO4, which is an acid. Now what will happen is, as per the reactivity series, zinc will be able to displace hydrogen. So if you see here, zinc lies above hydrogen, right? So as per the displacement reaction, we will get zinc sulfate along with the liberation of hydrogen gas. Okay, now this zinc sulfate is a salt. We will discuss more about salt in the later section. Now, here are two things which I need to tell you. Number one, not all acids react with metal in order to form salt and hydrogen gas. For example, nitric acid doesn't give you hydrogen gas as a product because nitric acid is a strong oxidizing agent. Therefore, as soon as the hydrogen is formed, it gets oxidized to water. Moreover, not all metals will react with acids in order to form salt and hydrogen gas. For example, if I take copper as a metal and I want to make it react with sulfuric acid. Now tell me whether this copper will be able to displace this hydrogen? No. See here in the reactivity series, copper is below hydrogen. Therefore, copper is less reactive than hydrogen and therefore it cannot move hydrogen from its place, and thus no reaction will take place. So one of the most important questions which is asked from this topic is, how will you test whether the gas which is emitted is hydrogen gas or not? For this we have a very simple experiment. Here in the test tube we have zinc granules, and these zinc granules is reacting with dilute sulfuric acid. So what will happen is, when zinc will react with dilute sulfuric acid, it will displace hydrogen from its position and will form zinc sulfate along with the liberation of hydrogen gas. Now this hydrogen gas is moved with the help of delivery tube to the soapy solution. So now the bubbles which comes out here contains hydrogen gas, and if you bring this burning candle near to the bubble containing the hydrogen gas, then these bubble will burst with a pop-up sound, and we know that this pop-up sound is created by the hydrogen gas only. So what will be the test for hydrogen gas? It would be, whenever you bring the burning matchstick or the burning candle near to the bubble, and if the bubble burst with a pop-up sound, it means that the bubble was of hydrogen gas. Now here's concept 4, which is related to this concept, which states that acidic foodstuff cannot be kept in metal vessels. So have you seen that your mother never keeps curd in bronze, brass or copper vessels? Have you wondered why? This is because curd contains lactic acid. Okay, we all know about this. Now this lactic acid can react with the metal vessel, and that metal vessel can be anything. It could be a copper metal vessel or a bronze or a brass, and on reacting with that metal, it can form a very poisonous compound which is injurious to health and cannot be taken, right? That is why we will never keep any organic acidic substance into a metallic vessel. Now let us see the sixth property of acid, which states that acids react with metal, carbonates and metal bicarbonate in order to form carbon dioxide gas. So let me tell you one thing, whenever you have carbonate in reactant, you will always get carbon dioxide as a product. Okay, say suppose I am taking an example of sodium carbonate, so its formula will be Na2CO3. Okay, now it is reacting with an acid which is HCl, hydrogen chloride. So what will happen is, first of all write carbon dioxide here, because carbon dioxide will form. Okay, then you need to write which salt will be formed. So Na will combine with Cl and will form NaCl. Okay, along with the formation of water. Okay, now let us see if this is balanced. So Na is 2 here, so I need to put 2 here. Okay, now Cl has become 2, so I need to put 2 here in order to balance. If you see here, the equation is balanced. Now many a times it is asked that how will you tell whether the gas which is emitted is a carbon dioxide gas, for which we have a lime water test. Now here let us see the example of metal bicarbonates. So what is metal bicarbonate? Bi means hydrogen has to be in between. Okay, so let us take the example of sodium bi, it means there has to be hydrogen here, and carbonate it is CO3, and it is reacting with HCl. Okay, now since we have carbonate here, then it is for sure that we will get carbon dioxide as one of the product. Now what will be the salt which will be formed? It is again NaCl along with the liberation of water. Okay, so if you see, the equation is balanced. Now let us see this lime water test. Now here if you see, we have sodium carbonate and we have dilute HCl. Okay, now when sodium carbonate will react with dilute hydrochloric acid, then a gas is formed. Now this gas is allowed to pass through this delivery tube into this test tube. Okay, now this test tube consists of lime water, and we have already seen in concept class that lime water is also called calcium hydroxide, and the formula for calcium hydroxide is CaOH2. It is also called slaked lime. Now when this lime water reacts with calcium hydroxide, then it forms calcium carbonate. Okay, now this calcium carbonate is basically white in color, Therefore, you will see that the white precipitate is formed, which confirms that the gas which came inside this test tube was carbon dioxide gas. So, whenever you need to test whether the gas which came out is carbon dioxide gas, you need to go for lime water test. Now, let us write the reaction for this. So, carbon dioxide, when it came in contact with lime water, which is calcium hydroxide, then calcium carbonate is formed. Now, limestone and marble, they also have the same formula, CaCO3. Now, this calcium carbonate is basically white in color, and thus you will see that the lime water is turned milky. Okay, now the question arises, what will happen if this carbon dioxide is kept on passing to this test tube? Okay, so we know that calcium carbonate is formed here and we are again passing carbon dioxide. So now what will happen? This calcium carbonate starts reacting with carbon dioxide because we have not stopped the insertion of carbon dioxide right now. So what will happen is this calcium carbonate will react with carbon dioxide and will form calcium hydrogen carbonate. So what will happen is we will have the equation calcium carbonate, which is formed here, will react with carbon dioxide. I should rather say it is excessive or carbon dioxide along with water. So the slaked lime consists of water also, that is why calcium carbonate will react with excessive of carbon dioxide and water in order to form calcium hydrogen carbonate. And what is the formula for calcium hydrogen carbonate? It is CaHCO3 whole twice. So basically Ca is +2 and bicarbonate CO3 is -1. So when they will cross multiply, formula comes out to be CaHCO3 whole twice, which is calcium bicarbonate. There is one important point here, that the carbon dioxide doesn't support combustion, thus it can extinguish any of the burning substance. Therefore, it is used by the fire extinguishers. Now the next is acids reacts with base in order to form salt and water. This is basically a neutralization reaction. Okay, so what happens is whenever you add base to an acid, so base nullifies the effects of acid and you get neutral salt along with water. For example, we have an acid here which is HCl and it is reacting with a base which is NaOH. Okay, now what will happen is it will form NaCl and water. Okay, now this NaCl is a neutral salt along with water. Water is also neutral, so the product is neutral, and therefore we would say it is a neutralization reaction. Now the last point is acid when reacts with metal oxide. So what are metal oxide? When any metal reacts with oxygen, it is metal oxide. For example, if copper is reacting with oxygen, you are getting copper oxide. Okay, or magnesium is reacting with oxygen, you are getting magnesium oxide. So these are basically metallic oxide. Okay, so these metallic oxides are basic in nature. That is, if you dissolve them into water, it will liberate OH ions. Okay, now when these metallic oxides react with acid, it forms salt and water, and this is obvious because we have acid and in place of metal oxide I can write base. So we know that acid and base gives the salt and water, and this salt and water are neutral in nature. Okay, moreover, if you have acid with metal hydroxide could be calcium hydroxide, magnesium hydroxide and so on. So these hydroxides are also basic in nature. So whenever you have acid with metal hydroxides, so they also give you what? They also give salt and water, because we know acid reacts with base to give salt and water. Congratulations, you have completed the most important topic of this chapter, which is properties of acid. Now let's just summarize it. So first we studied that acids are sour in taste because of the presence of H+ ions. Next, They turn blue litmus paper red. For this I told you the mnemonic ABR. Acids turn blue litmus to red. Next is they conduct electricity, that is why they are electrolytes. Weak acids are weak electrolytes, whereas strong acids are strong electrolytes. Next is they have corrosive nature. So accidentally if they fall on skin, they can cause burns, and if they fall on cloth, they can cause hole on the cloth. Next is what will happen when acid reacts with metal. So when acids react with metal, it forms hydrogen gas and salt. Next, what will happen when it reacts with carbonates and bicarbonates? So whenever you have carbonates, so in product you will always get carbon dioxide gas. So it forms carbon dioxide gas along with the formation of salt and water. Next is, this is all about neutralization reaction. So when acid reacts with base, so base neutralizes the effect of acids, and thus neutral salt and neutral water is formed. Last is what will happen when acid reacts with metal oxides. So metal oxides are basically basic in nature. So when acid reacts with base, it forms salt and water. So we are done with this topic. In the next lecture, we are going to study about properties of base. For this, subscribe to our channel and do click on bell icon. I'll meet you again. Till then, bye bye and take care of yourself.